Great. Okay, so let's start. My name is Tomasz, and thanks for a nice introduction. I'm an engineer in Synadia. Synadia is a company that is maintaining NATS technology, and I joined Synadia at January, and before that I worked at various domains and various companies spanning from IoT companies where I led with architecture, and then before in banking, Vodino Bank as a service, let's call it. That's provider for Ion. When I was leading the development of core banking written in Go, and previously in um, SAP as a lead of architecture of the infrastructure. So that was my background, and through whole my career, I was more or less interested in NATS and using it for different purposes, especially in IoT. Yeah, so in January I joined Synadia to start working full time on NATS, and here I am to tell you a little about how are things in especially Jetstream. So if you have any questions or other things, just interrupt me and say whatever you want to say. Don't wait to the end. I think that will work better in that organic way. Okay, so about Synadia itself, I don't know how many of you know that actually Synadia is the company that's being a lead development and maintenance of whole NATS ecosystem, with Derek being our CEO and also creator of NATS. We have very strong R&D team of engineers with huge experience in distributed systems. And we also, as Synadia, offer the NGS, which is a global NATS solution, very easy to connect and to use NATS without any need to set up your own environments. About NATS itself, it started growing recently even faster than in the past, especially after introduction of Jetstream and recent key value and object store. So we are growing pretty fast. I will not quote the numbers; you can see them on the screen. We are also adding new clients and support to them. So we're trying to reach as a NATS as wide audience as possible to support not one or two stacks, but all of them. When it comes to NATS itself, don't raise your hands because I'm sharing the presentation, but any of you are using NATS in production or in general?
So we got two people.
Okay. So yeah, so that's some audience that is already accustomed with it, but basically it's a very simple to run and to administrate and very performant messaging system that was at first just pops up and request reply, and then on top of it we built Jetstream, which is persistence layer for NATS. We've added values that I will talk about later. What is very important, it provides great capabilities for edge devices with unique Lymph node feature. I will not talk in depth about it today, as I think it's out of scope of this call, but I will hint it a little. And we've built in true multitenancy and advanced security, which allows for actual zero trust approach for messaging. Okay, so as this is a Kubernetes related meetup, I decided to say just a few words about how unique deployment of NATS can be and the topologies that is possible. So as I said, it's very easy to run, which is a nice thing, as messaging systems are often not that easy to run on various systems. And for NATS, you can run it, maybe go from the bottom. You can run it from very small devices like Raspberry Pi or some edge devices. Basically anywhere that you can run running compiled Go code. on bare metal, and of course on, especially recently, on Docker and Kubernetes setups where it's fully supported. And when the whole community put a lot of efforts to develop and improve the Helm charts for NATS. About the topologies, there are quite a few. Actually, you can mix and match. And just going briefly through them, the first one is just very simple, a server with clients connecting to it. This is usually for small setups or for POCs, etc. And then pretty quickly, usually grow, especially in Kubernetes setups, to the cluster. And what's important about the cluster, that it provides high availability, fault tolerance, and disaster recovery in various setups. So this is usually the default one when you try to run NATS in Kubernetes, and it's fully supported through the Helm charts. Then there is something a little more unique, which is superclusters. What's about them is that you can connect different NATS clusters across networks, across localizations. And this is what we do internally for NGS also. That the superclusters can be spanned across many regions. So you can spin one cluster in one Kubernetes, and then in another location have another one, and then connect them through the gateways. So this allows for really nice geolocation capabilities, etc. Then there's the unique thing I said I will hint, but not go in depth. But I really like that feature, so I couldn't avoid at least saying a little about it, which are Lymph nodes. And Lymph nodes, it's what works great if you have, for example, edge device or many edge devices in IoT. When you want those edge devices to be connected to the cluster in the cloud, for example, and have them working whenever the connection and the link is up. Especially if any of you work in IoT departments, you probably know how hard it is to get stable connection. And the Lymph nodes, what they provide is the ability to synchronize the state of the cluster and of the Lymph nodes, automatically reconcile the state, and have it consistent, eventually consistent when the connection is up. When the connection is broken, it will just, the Lymph node work as a NAT server itself. So you can, on the edge side, on the right side, you can still, all your applications can work flawlessly with NATs, publish messages there, etc. We communicate internally with other services. And when it will reconnect to the connection will be reestablished, then all the data that was persisted of streams, for the streams that are configured to be, of course, synchronized, they will be synchronized between cloud and Lymph nodes. So this is growing use case, and I think it's pretty interesting. And of course, you can mix and match, as I said. You have a lot of, you can actually do whatever you want. You can have super clusters with connected to superclusters, and those superclusters can have Lymph nodes. So the possibilities to set things up here are pretty vast. So yeah, I will not go through the basic NATS things, at least for now. I will try to go while we talk. I touched those that are related to Kubernetes mostly and the infrastructure. So going straight into Jetstream, what it is. So NATS, as its core, as I said, was mostly PubSub that could leverage also request reply pattern, but it was not having any persistence layer. So any capabilities that are related to streams were not possible. And there were previous iterations of STAN, so NATS streaming server, yet those were pretty complex, and Jetstream is, you can say, just next generation of that. So basically, this persistence for NATS. It provides both file and memory storage, and a lot of streaming capabilities, which I will show you in a minute. It replaces STAN, and what's interesting, what's important also, that it's built on top of core NATS. It's not something different. next to NATS core NATS. It's just built on top of it using the core NATS API, which makes, for example, developing libraries for new programming languages pretty nice, because knowing core NATS allows you to have Jetstream capabilities pretty easily implemented. It is also distributed and consistent. As I showed you those possible topologies, you can have clusters, superclusters, etc. And Jetstreams themselves use optimized for NATS use cases Raft algorithms, so that provides fault tolerance and disaster recovery. They can be replicated from 1 to 3 to 5 replicas, and also you can stream and source streams in between. So that's what you can do. You can source or mirror streams between different superclusters, different cloud providers, etc. So you can actually interconnect your multi-cloud setup or multi-regional setup pretty easily, and without any manual operations on backups, etc. You can achieve fault tolerance and disaster recovery that could be more or less fully automatic and zero downtime, I found that's pretty nice thing for that to have out of the box. What else? For those who are aware of NATS security system and how multi-tenancy works, the Jetstream have full capabilities of that, so it does not lose anything. And about streams themselves, they can have multiple sources, and consumers that I'll explain in a minute can filter on different streams, different patterns, etc. There are many different retention policies. So when you have stream, you can treat it differently and have a retention for days, for number of messages, or for like work queue. Whenever a message is consumed, it's done, or for interest, which means that as long as somebody is listening, those messages will be there. Different use cases for different purposes. Also, very important thing, especially when I was working in banking environment, is exactly once deliveries. That was missing in previous in core NATS, obviously without persistence. Now with Jetstream, the exactly once deliveries are there. So all those systems that rely on that capability can now leverage Jetstream and be happy with it. About the replay policies, we also talk about it in a minute. I told you about streams and consumers, which sometimes is confusing for newcomers. So a short, more elaborative talk about how the NAS architecture looks like in a very simplified way. When you have in the middle the NAS server, for simplicity, I just used one. You have streams that you can set up that are consisting of many subjects. And you can set those subjects as you like, with wildcards or with many subjects for one stream. And you actually publish messages just like with normal NATS, core NATS, with just simple publish to a stream. You can have a more advanced publish that allows you to have acknowledge of that publish that is needed for different guarantees. And then on top of the stream, when you want to consume messages from it, you create consumers. And that is why I want to show it as a chart here, is because those consumers are actually held on the server side. And you create a consumer that can have a subset of the subject of the stream with different wildcards, and that will track the state of applications that connects to it. So you can set up the consumers that whenever the connection is down, the application is restarted, it will continue processing where it stopped. You don't have to worry about the state. Don't have to store the last received message on the client side in the database, etc. You can just leverage the consumers to do all the work. Though there are also ephemeral consumers that will just be created on demand and just consume the stream. So that's the basic, very basic high-level architecture. The takeaway from here is that the consumers are server-side, so they track all the things that is happening. Are there any questions so far? Okay. Okay, so maybe just to, I don't like only talking, so now let's move to the part when things start to fail. So try to do some live coding session to show you how simple it is to run those things. So, sorry? Oh,
we're adjusting lights in the room.
Yeah, and can you zoom in on both
The sides,
sides of that?
I don't know. We've got some TVs you can see better on almost sometimes.
okay, but are the fonts okay?
Yeah. You're good. You
Okay.
might make it a little bit bigger, but that's
Let's see if it will not break my whole layout. Yeah, it should be fun.
I mean, don't, no.
It didn't.
I'm sorry. I like the split screen.
Okay, it's fine now, or even bigger.
That's great. I can see it.
I'm getting into risky territory of breaking Tmax.
That's a great size for us.
Okay, so let's start with this. Sorry, I just cannot handle errors. It's just beyond me to do it. Okay, so
We know some people that agree with you.
Oh yeah, feel free to move up. The TV's a really good thing. The TV in the back is great.
okay, so basically to just have a JetStream set up, you just need NATS connection. I used Go client. I didn't know which one to use. It's not like I can use all of them, but I decided that Rust might be not the easiest to grasp. So I hope it's okay. Go code is pretty simple and straightforward for such simple cases. So to create a JetStream context, which is called, you just need to make the command on the NATS connection. In different clients, it's sometimes implemented differently. It could just be JetStream, some kind of JetStream method that accepts as a dependency the NATS connection, or it could be like it's here, there's just a method on connection. It's pretty consistent across clients, though with some minor differences to be idiomatic for a given language. Yeah, but that's basically it. And now we can start doing things. So as I told you about the consumers. So there are two kinds of consumers. And I don't want to get too deep into that. So I will just say that there's push and pull consumers. The naming is a little misleading because it doesn't mean that you have actively pull for messages like it's not real time. It can be as fast as the push approach, though they have little different use cases. Yet it's important to notice that recently we made a lot of improvements on the pull consumers, and they're slowly replacing push in most of the departments. Okay, so we need here a name of the stream, and we need a name of the consumer. Okay, so what we can do here is having this. Let's do one thing. Let's publish few messages so this consumer can do anything. As you can see, for those using NATS, I could call the publish method on NC being NATS connection, and that would also work for the stream if the stream is listening for the subject. Though if I will do it on the JetStream, I will get the acknowledgement from the stream that stream get that message. So I'm just using that. So the subject being events, and yeah, let's. Oh, no. Okay, some data. We don't care. Okay, so yeah, we don't need that for now. Okay, the soup is not yet needed because I want to check what I did wrong here before. Yeah. Okay, so let's see if it works. But it didn't. And it didn't on purpose almost, because as you can see, I got the error that there's no stream that matches the subject. And that's because we didn't create the streams yet. So what we will do is we will use the NATS CLI, which is a pretty convenient tool to operate in CLI with the Jetstream.
Is it typical that you would do this with CLIs, or is there also functionality in the Go SDK to do that?
Yeah, that depends, right? And for production use cases, you mostly use that in the code, right? You have somewhere in the code the setup for the streams, for the consumers, etc. Though when you play with it and when you're trying to set up your how you want to model the streams, etc., or want to benchmark things, the CLI is pretty good for that. So.
Okay.
Usually, when you're doing changes and some adaptations, etc., you use the CLI, and then just because it's simpler and easier, and then you move. At least that's what I usually do. Move them to the code so you can have it full control over it.
Okay.
So the CLI, and I wanted to use it to show you what are the possibilities of the stream. So let's call the stream events. The name it doesn't have to correlate to the subject we're getting. So. And now what we can do, we have to specify one or more subjects that this stream will consume. So you have normal subjects in NATS, and the subjects are consistent of tokens. So you can have like events, data, whatever. And you can match by each of those in many different ways. So if we will do this, we will match everything that is events dot whatever is next, how many tokens there are, it doesn't matter, it will match everything. If we'll do this, it will match only the next token. So it will not match any next one. We can do also even something like this, which will match events whatever and then data, and then whatever is the rest. But I don't want to go to the details of because all of this is core NATS. It's pretty simple to use. For now, we just want to focus on the Jetstream. So I named and to match with the code what you're listening to. And now we have to choose the storage backend. We'll choose file. And then this is the thing that I told you about the possible retention policy. You can have limits that will basically set that the message will be persisted for duration of time, number of messages, size of all messages, etc. So there are many different ways you can configure it. Interest will keep the messages as long as some consumers are listening for them, and work queue, basically whenever the message is acknowledged, it will just be deleted from the stream. Let's go with the limits first. Discard policy. This applies when your stream is full. So let's say you have 10,000 messages limit set. We will see the limit soon. So if you'll set old, the old messages will be discarded. And if you'll set new message will be discarded. Again, different use cases. Usually it's old, and that's what will pick. So this is the stream messages limit, how many messages you want to have maximum as retention. Yeah, we can specify like 10,000 or like 100,000. It doesn't matter for the demo. And this is quite a new feature for those of you that were using Jetstream before, because we can set the number of messages per subject. So it's a separate configuration that's for stream. You can have set limit for 10, and for every subject with exact tokens that you'll get, it will just discard the messages that are going beyond this limit. Stream size limit. Oh, this nice thing is that for most there's a helper. So combined size of all messages. If you want to use that, we'll skip it for now. Age. This is another thing we can set. For example, that message will be persisted for 7 days. and individual size of one message in bytes, how you want to manage them. And any of them, if you will choose the first limit that will kick in, this will be treated. So you can have many actually set up limits at the same time if you need that. And just the system will react properly to the situation on the setup. Quite often you might have, for example, 7 days and some high limit for incredible for output, or maybe you just don't care and you have to have retention, for example, in banking environment, and you have to, no matter what, store the messages for 7 days, so you don't set just the stream message limit, and it should work fine. The duplicate tracking time window this is what it's needed for exactly once. What it does, it sets the window in time, in duration, for how long we will look for the duplicates. So the client can set the ID of each message in headers, because NATS can have headers. And what we'll do, that's when you consume the messages, when they're published, all the duplicates in that time window will be removed. So you can adapt the time window. Of course, usually it's pretty low, because making it higher and higher affects the performance in some way. Rollups allows you to delete messages up to some point for the stream. You can say yes or no. Message deletion is also added feature that you can delete specific message from the stream by the sequence. Purging subjects it's as it says, it does not delete the stream, but all the messages in it. Replicas, and this is what I said about high availability. And disaster recovery is maybe not disaster recovery, but high availability mostly, that you can set of how many replicas for the data will be for the stream. As this is single node server, I cannot have more than one. Yeah, and that's all. You don't have to go, even if you use NATS CLI, for all the options I showed you, because you can have flags used instead. But I just wanted to go through you. I thought that it's the best way to show those features, just going through them and explaining them. And all of that you can also do in the JetStream management API for each client library that we support, and you can exactly the same thing do inside your clients. Okay, so we have a stream, and now when we run this app again, we should, yes, we were able to publish the message to the stream. So we have one message there, but that's not much for us. So what we can do now is to show you how the consumer works. Now let's do, okay, we have the consumer actually here. So I'm wondering why it didn't fail, because it should. Okay, never mind. We'll see some. That's interesting. There is consumer here because I probably didn't delete it. Okay, so it should fail and it didn't. Sometimes it happens. I'll try to clear it out. So now if I'll run the application, it should fail with error saying that there is no. That's what happens. Yeah, the consumer is still here. Okay, I will pretend I know why it does not delete. It doesn't make sense, but let's go. Let's go forward. Okay, I will just comment those few lines with publication. So now what we can do, we can start listening for messages. And what you do in pull consumer is you call the method called fetch. So let's go here. Okay, and we can call. Why is it not here? It should be here. Okay. I got a stupid error. Oh, it's fine. Okay, so what we do in fetch if is that we specify the number of messages we want to say the server that we are fetching. And just you can fetch by one, and you can fetch by more than one. The messages are, it's not like sending, give me the whole batch. It will get, you will get the messages straight away. It's a little different behavior than the push consumers, which just subscribe to the consumer and the server will send you messages. Though this is pretty internal, and we'll in the future implementations we'll probably improve it, so you can pull the messages the same way for push and pull for pull subscriptions. Just the takeaway from here is that it's not actually like the polling approach for the stream. You can still have real-time approach. So as we fetched messages and set it to fetch only at most one, what we'll do is we can print the message. Maybe not this way. Let's get. Okay. I'm just, I know that I shouldn't do this, but I know that I will get only one message here, so I don't care that much. Okay, so that's pretty simple, just for fetching one message. And what we can do here, and it's just part of the Jetstream, that we can this specific message acknowledge. And that's also part of the guarantees that you want to have, depending on if you acknowledge publishers and acknowledge getting the messages from subscription. We'll skip this acknowledge for simplicity. What I did wrong here. So doing it this way, we're fetching in the loop, we're fetching one message at most and acknowledge any of them. So here, of course, you can have any processing you need. And if the messages, if the process fails, you can knock, so not acknowledge, or you can just do nothing and it will be redelivered to you in some time. And that can be configured. If everything went well, you can just acknowledge the message here, and that way you don't lose consistency. So let's see if it still works. Yeah, so as you can see, we received some data. And so there's two messages that were there. Did I close it, or did I something wrong here? Probably timeout kicked in. What we can do, we can also show quickly. Yeah, didn't configure the timeouts. Yeah, but you can see we can publish more messages, and they're coming straight away to the stream here. You can set the fetch for bigger numbers, and what's pretty interesting is that you can have many actually applications getting this data from this one consumer. What I didn't like is that the consumer worked out of the box, so I didn't show you this. So I'll create second consumer. And this is the part I told you. This is for consumer. There are pull and push. Push looks like you subscribe normally. Pull is how I showed you with fetch. They have pretty overlap. I don't want in depth into the features of them. You can ask them in Q&A if you're interested, or just read through the docs. So we'll go for the push this time. And this is the start policy. So how you want to start consumer getting the messages? All the messages from stream, only the new one, on the last message, or message from subject and from, for example, time for like last hour, or for given sequence. So you can actually have pretty detailed policy for a consumer, how many messages it gets and which of them it gets. Then acknowledge policy. This is how the messages will be acknowledged. So if you said explicit that each message, as I showed you in the example on the left, has to be explicitly acknowledged. If you said all, whenever you acknowledge, all the messages preceding the one that you're acknowledging will be acknowledged. So this is really good for high throughput scenarios that you want to improve performance as much as possible. That's what it will do. You have like, let's say that we fetched here like 100 messages, and you don't want to act all of them. You can just loop over all those messages and just acknowledge the last one, and all of them will be acknowledged. Next one is instant or original replay policy. This is pretty interesting because instant is what you usually use because it instantly send the messages as soon as they're available, or if it's reading from the persistence, just as soon as possible and as fast as possible. And original, it will retain the rate and the time the messages were received. So it's really interesting for cases when you want to simulate, like in digital twins or other setups, or just for testing, simulate the behavior of the environment. So you can just, you will not get all the messages at once, you will get them at the same rate that were published. As I said, you can filter the stream further because stream can have many subjects and many wildcards, etc. Here we can filter it, narrow it down. Maximum allowed deliveries is how many not acknowledged messages can be there, and if the image is reached, we stopped sending, the server will stop sending messages. If there's not set, it will just send them endlessly as long as somebody will ask them, then they will just move forward. Maximum acknowledged pending. This is important as it sets how many pending acknowledges can be there. So as you can see here, I could fetch 100 messages, or I even could fetch one, but then I'll do with some of them a lot of things and I don't acknowledge them. And this policy sets how many messages can be not acknowledged and being fetched from the consumer, from the server. And this is important to retain ordering, strict ordering for consumers, and controlling the pressure on the client, how many messages are being sent to the client. And when the limit is reached, the server waits just for the previous messages to be acknowledged and before it sends the next one. This is sending only headers without the bodies. It's not important for NAS. The retry backoff policy. So there can be, when the message is not acknowledged explicitly, you can send the policy in what, and basically the retry policy you can set how often and in what time the messages will be retried. Yeah, and we select the stream. So we created the consumer with all the things and setups we wanted. And you can do manual creation of consumer to have full control over it and have it persistent on the server so the application can crash and restart and whatever, and it will start when it's stopped because the server will keep track of all the messages. Or you can just create ephemeral consumer. So when you'll just, I will not do it now because I will fail for sure, but if you'll do, for example, on JS subscribe, it will create ephemeral consumer. That will just create the consumer, fetch the messages from stream. It acts as you would just subscribe to the stream, though it under the hood creates this ephemeral consumer. So that's for the basic possibilities, capabilities of the stream. And now I will go to the key value and object store. But first of all, some questions to answer. Do you have any, guys? Angor, sorry. No?
Nope, everything seems quiet over here.
Sorry?
I said nobody's raising their hands. I think you're good.
Okay. Yeah. So as Jetstream, we're making a lot of improvements on it with help of community. And that allowed us to have a crazy thought that maybe we can provide something more like key value storage on top of Jetstream. So yeah, we tried it and it actually worked. So what it does is that not in all clients yet, there is the capability of having the key value. So to have the key value, let's create key value. Now I'll just I will not go through all the options here, but probably two of the most interesting. Let's just so when you create key value, what's interesting that it can have history. So this is basic key value but we say that it's a history of 10 messages. So you can go for back and forth and read them. And as you can see, probably you can see it's built on top of Jetstream because I use Jetstream API. So as we create a Jetstream context from NATS connection, you can create a key value context. And yeah, I cannot do anything with it because yeah, key value error. And now we can do some things. And I see that I am way over I expected of my time, so I'll just not do everything, but just tell you. The most important thing is to create and put that will just add a new key with respective value to it, to the key value. But first you need to create a bucket. I created the bucket with the first command, and bucket can contain a set of keys and values. Then there's a delete method. What it does is it deletes the key, but sorry, it does not delete the key. It deletes adds a key delete, so it's non-destructive. It adds the delete operation to the key value. So and when you try to get this key, you will not get it. You will get the no key value error, though the things are still there. All the key values are there. You just don't have access to them. So this is non-destructive deletion that allows you to revert if you want to. It's pretty nice for audit or things like that. Then get is self-explanatory. It just gets you the latest revision of the given key. This returns all the keys. And this will return all historical values for a given key. So you can get all the values. Purge deletes all the revisions, so it just cleans the key value from everything. It's different from delete. It just purges the whole key value. Purge deletes removes the deletes, and this is and watch is also interesting because you can set a watch to operate on to see all the changes in the key value. So to show it to you how it works, let's just in this code, what we'll do, we just create the key value for now. Yeah, let's go. I know. Okay. Stream name already used. What did I wrong here? I'm not trying to add any stream here. Let's just probably I just played with it. I'm hoping that this is it. Yeah. So okay, so with the CLI, which is pretty convenient for the key value, you can see that there are few buckets, and one that is the pretty new one, the key value new. And what we can do now is we can watch, let's say, key value new. Yeah, that's so what we did. We started to watch the key for the key new bucket, and if we'll run it again, I just put. No,
On
what did I
the
wrong key?
stream object.
I'm pretty sure it's no on the key value, and I created key value here. Undeclared. Ah, okay. Sorry, that was this. Hopefully, yes. Okay, so we define the key here. We are watching for new, and we pass the slice of bytes. I don't know, value. I don't want to go to like crazy things. And this does return only error or also revision. Yeah, revision and error. So revision will skip, error. No new variables. Yes, of course. And what will happen now, watch at the top of the screen. Whenever we get a new value, the watch will just print them. So you can have a history for those keys. Let's see it. So you can see all the values that were previously, and delete. It was not delete. Del, okay. And now if I will try to, I will get the history, I get the whole history, but I'll try to get, I will not get it because it is not found. So it's pretty nice if you want to have that. What is interesting that the key value was recently by our colleagues from different companies actually implemented as a persistence backend for Kubernetes. It was implemented for K3s because, as you probably know, the K3s by default uses for the state of Kubernetes the SQLite. Yeah, yes, it's SQLite, and right now I'm not sure it probably is already available. You can also use the key value from NATS as a layer for persistence of Kubernetes cluster. We're still improving on that, but it's there, and I think it's pretty exciting to have this integration with NATS and Kubernetes.
Are those values limited to the same size as normal messages, like a 1 meg limit?
Yeah, you can set the limit. The limit is not like hard coded. You can change the limits, though. Of course, it's the changing the size of the message affects the performance, right? If you have a lot of reads on big messages, it will get less and less performant. But yeah, you can increase the size to arbitrary numbers.
So you could increase it to like 1.5 or whatever etcd usually has?
Yeah, as long as it's reasonable, like few megs or something like that, that's fine, right? Just I will not go with like hundreds of megabytes. For that, we have one more thing that I'll show you in a minute, but let's hear a question first.
Also in the cube code itself that they do those limits, so it's not purely, they set that higher
So
up
I mean,
as
this is
well.
like lightweight etcd.
Yeah. I have a couple.
Yeah, that's a good description for it, right? It's not like we're not trying to blow out the competition from the key value domains. We just saw a great opportunity to have nice key value, pretty simple, lightweight key value there with some nice capabilities, because what it's good that the whole topic I told you about the disaster recovery scenarios and replication, etc., it's all still here, still relevant, right? Because under the hood, the key value is just a stream, with specific settings. So that's all it is. Though of course it does not have all the possible features. We're adding some of them still on top, but it was enough to have it as a persistence for Kubernetes, for example.
So does it do things like all of the consensus rights and stuff behind the scenes? So say your JetStream, your stream was a three server stream. If you do that with etcd or traditional key value storage, you got to have your clients talk to every single endpoint. One of the things I loved about NATS was you don't have to know about every endpoint in order to deal with clustered endpoints. Is that true for the key value store as well?
It is.
Oh, that's so much nicer than dealing with etcd, 3 or 5 different addresses for every connection.
Yeah, you don't have to deal with it. It's just exactly the same with normal NATS. No differences here. So maybe I'll show, because questions about the size are there. I will not write the code for it, because I think that I limit my lack capacity for today, and it will fail horribly for now probably. So what we can do is, there's also object store, which is less developed than the key value. So just a sneak peek for you. What it is, I don't know the API that well yet, but okay. What we can do is we can add new bucket. Let's call the bucket let's call the bucket. And what it is, it's actually allows you to have files, kind of storage for files on NATS using, again, JetStream. So object, okay. So NATS object, put, how I called it, bucket, okay. The file is just file that I have here, probably. It's just some few 80 megabytes or something. And yeah, it was already there. As you can see, what it happens now, it's slow because I run NATS server in debug mode and trace mode, so it prints every byte here. Let's not do this. That should be much better. Almost immediate. So that what it does, it's still under the hood use JetStream, but it just sets the chunks, each message to not have, as you asked previously, 80 megabytes, leave it for message. I don't know if it will even work. Probably not, or if yes, badly. It will just chunk the messages, chunk the file into smaller messages, and then when you retrieve this file, it will ensure ordering, so all the chunks are received in exact order. So you basically get some simple capabilities of object store here. I will not go into much details of using it. I can show you one more slide about it. Yeah, let's go back for the slides. Let's see if I missed something for objects for key value. I guess I covered most of it. Yeah. So when it comes to object store, it's as JetStream. It has encryption and rest and replication, the same as the key value, and you have the seal method. So when you seal the object, you can, as you saw, I was just overwriting this file in the given bucket. What you can actually do, you can seal it, and then it will be immutable from that point of time. And you can have the same history for files and watch, similar to the key value watch, so you can get the notification when the new file for a given bucket arrived. So that's basically it about the object store. Any questions about it?
So NATS does NATS have persistence? Like I know it's normally in memory, but like an object store only in memory is a use case, but it's a
Yes, it has file. It has two persistence modes. It can store in file, or it can store in memory. So when you set up Jetstream, it will just set up you some directory and will store all the files. All the persistence is there.
Jetstream is the persistence layer around.
Yes, just exactly.
NATS is just messaging. It just
Gotcha.
routes stuff. Jetstream stores it. It used to be Stan was the thing. That's deprecated. Jetstream is the better way to do it.
okay,
Yeah.
that makes more sense.
Yeah, what is interesting because having messaging system is pretty easy unless you want to have retention, right? But actually in NATS you can see or you can yeah, everything I need to do is of course for the simplest cases, right? It's just to pass the Jetstream flag and it will just have Jetstream. You can of course configure where the files will be stored, etc. How many how limits are set for how many megabytes, etc. But basically for simple cases or like if you don't want to limit the storage capacity because it's not production, you can just set the Jetstream flag for normal NAS server. You don't need any sidecar or anything, and it will just be there. And all I did is this to have all these features with key value, with streams, and with object store.
And is the object store like generally available, or it's still kind of in development? What's the actual state of
No,
it?
it's this object store is in development still. The key value is closer to being GA. I don't want to name the date yet, but it's pretty close. It's in most clients already implemented. And when it comes to object store, it's not that close yet. It's available in clients in Go, in Rust, in Java, I guess, in .NET. I might be wrong. For sure in Go and in Rust it's there. Key value is in Java, .NET, and Node and Dino. Yeah, I don't just you would have to check what library you're using it, but object store is in less than key value.
And do you have like guidance on how large you're hoping to aim for with the object store? Is it something, for like static assets of a web page, or potentially gigs and even terabytes of data at whatever you kind of want?
The limits of the Jetstream applies, so it can be huge. It's just the question of it's not the fastest things ever, right? It's built on top of Jetstream, so it can be pretty fast, though it's for sure not covering all the possible use cases. So the size is not the biggest concern here, probably, because as I said, Jetstream itself, we have users that have like millions of messages in the streams, right? So it just translates somehow number of chunks stored in.
Cool.
So just to sneak peek into the future a little, what you should, you might seen it in some roadmaps. What will work soon in the future. Some nice tools for client migration, integration with WebAssembly and functions. Some integrations with big data, so we don't have to manually do anything in terms of ETL. We could just rely on the integrations. More support to WebSockets and schema management and service registers. There are more things coming. You can check them on the roadmap. It's pretty up to date on the NATS server, if I recall correctly. Though this is just a sneak peek of what should come next. Any questions so far?
Good.
Okay, so one last thing is.
We got a question.
Sorry,
Yeah.
this is really off topic, but can you point us to more documentation on the Lymph nodes?
Yes, I'm happy that you asked that because it's my favorite topic. Give me a second. Oh yeah, I know that you could do it yourself, but I have my Google loves NATS documentation for obvious reasons because I'm there pretty often. Where's the meeting? I lost where we are. This is okay here. Sorry. Why I cannot get it back? Where is it? Ah, okay. Sorry. Okay, so I'll link the docs. I have to exit this one. Okay. So what's the biggest use case for Lymph node I use mostly, and I was using in IoT, is to set each edge device can be a Lymph node, right? And for example, if you have factory floor, you can have a Lymph node server there, and all the edge devices in that factory will communicate with that Lymph node, and send. You can have JetStream also enabled there, and then the huge cluster in the cloud for like aggregation of all the data, for example, that will aggregate the data for all the, it can be thousands of Lymph nodes. It will gather it to allow you like the global overview of the system. Oh, I could, if you trigger me to talk about Lymph nodes, we we could stay for long here. So I'll just shut up now and not go further. Just read the docs and just reach us out. I encourage you all guys to reach us out on Slack because we're trying to be very active there and answer questions and help you out. So feel free to reach us out there.
Thank you.
We're clapping. Yeah.
You done? Is that, okay, do you want, you had a last slide on your company.
Yeah.
I didn't want to
Yeah,
give you.
I have. Okay, one last slide is that the NGS I mentioned, it is, yeah, it pays the bills. It's which is what is really interesting. I was using it. I was not still in Synadia. Is that it allows for a global actually access to NATS, so you can connect the factory like in, I don't know, end of the world somewhere, and second in another end of the world, and you will have very pretty nice latency from each because they will both connect to the closest NATS there, and you could just use it as it's just a NATS server with some added capabilities in terms of infrastructure setup, not new features, just how it's set up for the customers. It's really great if you want to, for example, connect many cloud providers and don't want to deal with setting up the clusters, or if you want to connect, this is what I was doing, factories from all over the world and don't care about VPNs and interconnecting all of them. You just from each connect to the NGS, and you have all you need there from each Lymph node or each factory. It has very high availability because this is very big setup with all these features of replication and DR being multi-regional, etc. And I think that the pricing is also very interesting. So I encourage you to check it out. It has very easy onboarding for the free tier clients. So just you can go to the Synadia website and just test it if you like it. Okay, so that's all from me. Thank you for having me here. It was very nice to present to you. And yeah, that's all from my side. Okay, any follow-up QA questions? Do you have any?
Any more questions? No, we're good. That was awesome. I love NATS. I think it's great. I think it's way better than Kafka. So
Thank you.
We're gonna be frank here. So we really appreciate your time. I'm sure it's super late for you, so I'll go ahead. I'll stop that recording. You're welcome to hang out here. I'm not gonna say as long as you want because last time I said that I was here until 11. So you're welcome to hang out to any reasonable time. Thank you so much.
Thank you very much. Thank you for having me.
We will let you know when that video is on our YouTube so you can share it or use it for whatever you need as well.
Okay, great.
There you go. Just solve all
Stop
your
recording, but I know Todd
storage
waits for me to
bucket
do this.
problems.
He's always very excited to stop recording.
NATS is great at routing messages.